Good morning, students. This is Satyanarayan here. Today I am going to explain you the various functions of the function generator and how we are going to use the function generator effectively, particularly in laboratories or as an examination. Say, as soon as you switch on this function generator, monitor that first case we have to say that the on-off control here, the DC offset control here, and the symmetry control, this should be in off condition. Okay, see like this. This is now off, and the symmetry as well. And one more thing, in this function generator, in symmetry, this should always remain off. Okay, and in DSP, there is, you can see that there is a DSP mode is there. In the DSP mode, this should be always in internal. So what happens if you select mains and externals? See that this mains simply shows the frequency of the 230 volts BISCOM supply frequency it is showing. There is no use, only the output you will get when you select the internals, and it will show the frequency here. Okay, this is a frequency counter. So next thing you have to do is you can vary the frequency by adjusting the frequency and course control. See that like this. This is a course control and this is fine control. Okay, next you have to see that the range in which frequency actually you required for one particular experiment. You have to select this. You see that there are different ranges are available here. 20, 200, 2K, 20K, 200K, 2 megahertz. So you can select the range here by pressing this like this. As soon as you press this, you see that the frequency is getting varied. Suppose if you select a 200 hertz range, what is the minimum and maximum frequency you can vary? So the minimum here is 20 hertz, maximum is 200. Suppose the next one, if you select 2K, what is minimum and maximum frequency you can select? Here the minimum is 200, is maximum is 2 kilohertz. Like that, in each range we have different ranges that can be varied in between. If you want to vary the 200 to 2K, then these two control will help you in that case. Addition to that, there is a function option is here. See that a sine, triangle, square, positive pulse and negative pulses. Here also you can select the function by selecting the pressing this key like this, sine, square, all these things. And the last one, the amplitude. So the amplitude control is here. The maximum amplitude is 30 volts peak to peak. In some function generator it is 20 volts peak to peak, and it is in decade range. See that? So the ranges between this you can vary by adjusting the level control here. By adjusting. So now I will demonstrate how exactly this will function, how to select the exact value, and I am going to explain this. Just monitor. Now you are going to connect a CRO probe here like this. Okay, lock it, turn it by, and you see that on the CRO some waveform has appeared. Because I don't know, you have to bring it down within the screen. For that you have to adjust this control, volts per division control like this. And I already explained that. See that I am going to press this function here. Just monitor what happens on this here. Triangle, square, positive pulse and negative pulse. If you go back again you will get a sine wave. So these are the function, and the frequency range. If I vary the frequency range here, just monitor. See the frequency range, it will vary, and again it will go to starting from 20 hertz and 200 range and 2K range, like it goes on like this. So the question here is how to adjust what we required for a particular experiment. Okay, for that we will see that according to one simple experiment called voltage follower here. So for the voltage follower, we need one 741 IC, and we are going to short pin number 2 and 6, and a power supply for this we are going to use a plus or minus 12 volts here, and I will show you how to adjust the CRO, what we required according to the experiment, and how to demonstrate. Okay, let us start this. So start the experiment begins with connecting a power supply like this. So in this model we have minus 15. We can adjust to even 12 also by controlling this, and addition to that there is a common terminal and a positive terminal. So this positive terminal is connected to the pin number 7 of the 741, and negative terminal here. This negative terminal we are going to connect to pin number 4, and the floating ground, this connection, this floating ground should go to the ground. Okay, so let us connect voltage follower circuit, and what specification actually we require, all this we are going to step in a simple methods. Okay, just observe the connections. Okay students, let us start the experiment. See the circuit for a voltage follower adjusted like this, and the important thing here is you have to select the power supply connections as I explained earlier. And if your power supply connections are correct, first you switch on the power supply and see that the output voltage should remain 12 only. In case, see, it is 12 volts. In case if this 12 volts drops to 0, then you have to immediately switch off the power supply and check the power supply connections here. Maybe wrong connection or something goes wrong. So this is the first thing you have to do it. Okay, now according to the circuit, let us adjust the signals as follows. Say I connected the function generator here. I don't know what is the amplitude or required frequency, everything we are going to use. So for voltage follower, I am going to adjust the frequency first. So I need 1 kilohertz. So 1 kilohertz means which range I am supposed to select. See that it is in this range. If you select 2K range, then you can adjust the frequency from minimum 200 to maximum 2K. So I need 1 kilohertz here. So this is the correct range for that. Now we are going to adjust frequency controls here by course control, adjust it and reduce this to 1 kilohertz like this. Okay, like this. If you want to adjust exactly value, then you use the fine control like this. Okay, roughly it is 1 kilohertz. Now the issue is how to adjust the voltage. I need the voltage 1 volt peak to peak, but there is no indication or counter here to indicate the amplitude adjustment. So in such a cases, what you have to do, first you see what you want exactly, because in this experiment we required only 1 volt peak to peak. Now you have to concentrate on CRO now. Already I explained how to operate the CRO controls. Now in this case I require 1 volt peak to peak. So you have to monitor the channel 1 where we connected the output and the ranges here. Because I need 1 volt peak to peak, you can select the range of 1 or 0.5. Suppose if I select 0.5 scale, so how many divisions I am supposed to adjust this here? Suppose the scale is 0.5, so the measurement of amplitude is like number of divisions on y-axis multiplied with this scale. So number of divisions should be 2 divisions. Now what you have to do? You have to adjust the amplitude. CRO will not do that. So now let us see the function generator. Bring it down and adjust the fine control and monitor here. Adjust the time-based control also for better understanding. So I have to adjust 2 divisions. Now I am going to adjust this function generator amplitude control. CRO will not do that. Simply it will display. So now you see that there are 2 divisions on this scale. So I already selected the scale of 0.5. So 2 into 0.5, 1 volt peak to peak. Suppose if I select the scale now 1, it should display 1 division. So 1 division multiplied with 1, again 1 volt. Suppose one more option. If you select 0.2, then how many divisions I am supposed to get? Because the maximum voltage I want is 1 volt peak to peak. If I select the scale 0.2, then I need 5 divisions I am supposed to get. So measure this, you will get exactly 5 divisions. So 5 into 0.2, 1 volt. This is what exactly you are supposed to adjust in the initial setting. Okay, let us go for the experiment actually. What you have to, let us see first how to set the input voltage. You know that the input voltage is connected to the pin number 3. So connect directly, don't bother what voltage you adjusted in the function generator, just connect it and adjust the function generator voltage, monitor the output here. So here I select the 0.2 range, that's why I got 5 divisions. If I select 0.5 volts per division range, then I will get 2 volt peak to peak. So if you want to change slightly, you can go for this control. Okay, so 1 volt, 1 peak to peak, I got it. This is what exactly you have to do. Connect the function generator to the circuit, don't bother what frequency and what amplitude, initial settings. Then take the CRO output and connect to the input. See, this input is connected here and I connected directly here. Now you have to adjust this amplitude control as well as the frequency and monitor on the CRO. This is the first work you have to do. You need not to connect separately on the breadboard and all this. It is simply time waste. So now you are going to connect. The input is okay. We adjusted according to our circuit requirements. Now we have to see the output. So the output at the pin number 6. So I am going to shift this to pin number 6 here, and I have to get 1. Same as 1 volt peak to peak. Besides it's a voltage follower experiment. See that. The output shows exactly what input is. So the output follows the input. That's why it is called as a voltage follower. Okay, so the phase difference between input and output is for the voltage follower is in phase. Let us, so now actually we need to compare the two waveforms. So at this position only you are going to go for the one more probe for the second channel. Okay, let us compare the phase angle between these two. Just monitor. Okay, again I am repeating you that initially use only one channel until you get the output what you are expecting. Okay, always select the output channel to the first channel of the CRO. Now we want to compare the two waveforms, then only you have to go for the second channel. This is very important and it will solve many problems. Now you get the trace by adjusting the second channel here. See, you got it. Now you connect the second channel, a probe, and because we have to compare input as well as the output. Okay, so now connect this to the input at pin number 2. Say I connected. Now I got output because I have not selected the scale of the second channel. It is somewhere, I don't know where it is, so it is far away. So reduce this exactly. See this, the scale here is exactly 0.5. So here is also 0.5. So you can easily compare this with the input. Now you can see that both are in phase. Okay, in voltage follower, the voltage follows the input and it is in phase. So both input and output is in phase. So that is the end of the experiment. And this is one simple way of checking the 741 IC. And you need not to go for a separate IC tester for 741 in bulk way, or then only you can use a simple IC tester. Otherwise, this is a simple technique to test the condition of the IC. I hope that so the similar methods are required. So I will repeat the CRO. After that, you check what input it is there, adjust the amplitude and frequency what you required according to that. Then select a proper channel on the CRO and display on the CRO according to that, and take care of the power supply before checking that. I hope this will help you how the function generator will work, how to select the voltage frequency quickly, and how you have to get the output. Okay, let us see in the next experiment. Thank you very much for watching this video.